Hello students. So today's topic is aldehyde and ketone. Before we start, please subscribe our channel and hit the bell icon to update it about our conceptual videos. So let's start. Now, what is aldehyde and ketone? Let us see that first. That is, for aldehyde, the group is C double bond O H, and for ketone, the group is C double bond O. Now, if this two functional group is present or added with any alkyl group, so that will be called our aldehyde and ketone respectively. Okay, so let us see an example that is like this. Now this R can be anything, that is CH3, C2H5. If CH3 added with this R, then we call it acetaldehyde. Okay, or now if we do it for ketone group, so it will be our acetone. That's how we decide that it is a aldehyde group and it is a ketone group. So that's how we distinguish between them. Preparation reactions of aldehydes and ketone. First one is, if from alcohol, if we want to derive our aldehyde or ketone from alcohol, there are many processes. Let us see that. First one is, if we react a alcohol with Ag powder, okay, and half O2 at 250 degrees Celsius temperature, then it gives us RCHO. Okay, that means the CH2OH gets converted in RCHO. There is no increase in the carbon number. The carbon number will be same as before. Okay, so let us see the next process, that is RCH2OH. You just have to remember the reagents. Okay, the product will be almost same. So it is CrO3 2C2H5N in CH2Cl2 solution. So it will give us RCHO. So you are seeing that the product is same, but the reagent is changing. Now, there's a special case, that is from allyl and benzyl alcohol. If we have to derive aldehyde or ketone, then what we will do? That is, let us see it for an allyl alcohol and a benzyl alcohol. Let's see it first for benzyl alcohol. So what we do? We give it a reagent MnO2 in CH2Cl2 solution. So it will oxidize this CH2OH into CHO without oxidizing the double bonds. So the double bonds will remain intact here and we will get benzaldehyde here. Okay. So let's see it for a allyl alcohol, that is this. Now again we are gonna give it MnO2 CH2Cl2. So it will give us the CH2OH is being converted to CH, no change in the double bond. Okay. Next process is from dry distillation. So this is one of the most important preparation reactions. So please remember it and listen to me very carefully, that what happens. That is, we have this alcohol here. Now what do? We just oxidize it. Then it will give us HCOOH. Now we are going to react it with CaOH whole twice. So now it will give us HC double O whole twice. Now we are gonna dry distillate it. That is our dry distillation. What will it give us then? It will give us HCHO. Now, if we see it for ketone, it will be more easier. Okay, so let's see it. That is, if we take this alcohol and oxidize it, it gives us CH3COOH. Now we are gonna reacting with it, CaOH whole twice. So it will give us CaCH3C whole twice. Now if we dye distillate it, writing it in short form, so now it will give us a ketone here. Okay, you got that? Now our next reaction is called Rosenman reaction. So it is a name reaction. So please remember it very carefully. Okay. So what happens if we take a acid? Okay. So this Rosenman reaction gives us aldehyde or ketone from what? Carboxylic acid, we can say, or acid halide. Carboxylic acid halide, it will give us only aldehyde. Okay, no ketone. Only aldehyde will be given by this Rosenman reaction. So let us see how that happens. That is, if we react it with PCl5, then it gives us CH3COOCl. Now, what we are gonna do? We are gonna give it the reagent, that is PdCaCO3 in BaSO4 and boiling xylene. Now, what will it form? It will just replace this Cl with one hydrogen. So it will be like this. So that's how it is forming an aldehyde group. So it is acetaldehyde. So that's how Rosenman reaction is forming aldehyde. So as you can see that this reagent has two parts. One is PdCaCO3 and one is BaSO4. Now this BaSO4 is very important because if this reaction happened without this BaSO4, then what happens? Then this whole acid halide gets converted into alcohol. So that will be CH3 CH2OH. Okay. So it shouldn't be converted to alcohol because we want aldehyde from it. So we give this BaSO4 in boiling solution, that will prevent it from converting into alcohol, and this CHO group will come. Let us see another example. That is, from this, if we give the same reagent, that is PdCaCO3 and then BaSO4 in our boiling xylene, it gives us benzaldehyde. So it gives us benzaldehyde. Now we are gonna derive aldehyde from cyanide. Okay, that is CN group. Okay, so now from if we want to derive aldehyde from cyanide group, there are many processes. The first process is from by Grignard reagent. Okay, Grignard reagent. So what is that? That is, let us take an example of HCN, and if we react it with CH3Br, and if we react it with CH3MgBr, what happens? In dry ether. Now, listen to me very carefully. That is, this CH3 comes on this C. Okay. So it will be like this. and this triple bond end gets converted into double bond. Okay, so then what will it give? It will be giving us acetaldehyde, right? Now we can also make ketone from it. So how can we make ketone from it? Let us see that. That is, if we take CH3CN in place of HCN and react it with C2H5 MgBr, now what will it give us in ether? That is, this C2H5 will go on to this, and this triple bond N will convert into double bond. So it will be CH3C double bond C2H5. Okay, you understanding it? So let us see the next process. The second process, so if we want to derive aldehyde from this alkyl cyanide, that will be our Stephen reaction. So please remember it very carefully. Okay. So because it is a name reaction, so let's see what happens. That is, if we take CH3CN and react it with SnCl2 plus HCl, what happens in H2O, boiling H2O? So it will give us this CN group, whole CN group will be replaced with CHO. You just have to remember that. Okay. So again, we're gonna see it for a benzene cyanide. So let's see it. It is SnCl2 plus HCl H2O delta. Then it will give us CHO, because this CN group is replaced with this CHO, right? So that is our Stephen reaction. Now let us see. There is another reagent that is called dibalage. So what does it do? It also replaces this CN with CHO group. It is 800 degrees Celsius. This CN group will be replaced with CH. Okay, but the most proficient way to derive aldehyde as a final product from alkyl cyanide, that is our Stephen reaction, and it is also a name reaction, so it is very, very important. If we want to derive aldehyde from alkenes, okay, so the process will be our Walker's process. Okay, so it is also a name reaction, so please remember it. So let's see it. That is CH3 CH double bond CH2. Now what do? We just add this reagent, that is PdCl2 H2O CuCl2 air. Okay, PdCl2 H2O CuCl2 air. So that will be our Walker's process. So what will it give us? It will give us this, okay, ketone. And if we reacted with this and added the same reagent, that is PdCl2 H2O CuCl2 air, then it will be CH3 CHO. Okay. Now next is, if we want to derive aldehyde or ketone from our alkynes, then what we will do? That is, we have also seen it in our alkyne and alkene chapter, but I am going to show it to you here also. That is, if we react this with 1% HgSO4, H2SO4, and 70 degrees Celsius, what happens? Product comes here, right? If you don't know how this product is coming, please go and see our alkane, alkyne, and alkanes video. That the link is given in the description. So let's continue. That is, it will do ketoenol tautomerism. So now it will give us this ketone. Okay, so that's how we do it. Next is from hydrolysis of gem dihalide. Okay, so let's write it from hydrolysis of gem or geminal dihalide. So what is geminal dihalide? That is CH3CClClH. If we just react it with NaOH solution, okay, so what will it do? It will form a OH here, OH here, and here a H. So now they will form this. So that's how we derive aldehyde from geminal dihalide. If we want to derive benzaldehyde, okay, benzaldehyde from our toluene, then what can be the processes? So let us see what is toluene first. That is, this is called toluene. Now there are two processes, okay, from where we can do it. So first one is 2CrO2Cl2 CS2 in H2O. So this is called our Itard's process. So it is a name reaction, Itard's process. 2CrO2Cl2 in CS2H2. So it will directly give us CHO. But there's another process where we can indirectly derive it. That is, if we react it with CrO3, CH3CO whole twice O, then the CH3 will be CH3 will be converted into this. It is OCHO CH3 whole twice. Now if we give it concentrated H2SO4, it will give us benzaldehyde. Okay, so this process is more efficient, so that is why it is a name reaction called Itard's process. Reaction is coming, that is Gatterman Koch aldehyde. It is Gatterman Koch reaction. Okay, so what is it? Let us see it. That is, a benzene ring is taken plus CO plus HCl, and the reagent is AlCl3 plus Cu2Cl2 in ether. So what are the reagent? That is CO, HCl, AlCl3, Cu2Cl2, and ether. And it will give us CH. Okay. So there is another reaction that is called Gatterman aldehyde synthesis. So first is Gatterman Koch, and it is only Gatterman. So that is HCN. If we react it with HCl in presence of AlCl3, it gives us a compound like this. Okay. Now this compound will be reacted with this in presence of AlCl3 again. So then it will give us a reaction like this. So if we add H2O here, we will get benzaldehyde. Okay. Oxidation. Okay. So the open hour oxidation is totally opposite thing of our MPB reaction. Okay. In MPB reaction, what is happening? We are converting the solution of aldehyde and alcohol to totally in a solution of alcohol. But here in open hour oxidation, we are converting a solution of alcohol and aldehyde totally in aldehyde. Okay. So let us see the reaction. That is, let us assume that there is a solution of this and this alcohol and this ketone. Now, if we react it with CH3 whole thrice CO whole thrice L, what will it give us? It will totally convert the reaction into this ketone. Okay, so that is called our open hour oxidation. Pinacol, pinacolone reaction. Okay, so what is that? That is CH3 CCH3. It will also has CH3. Okay, so what happens if we just give concentrated H2SO4 to it? One of the OH will go out. Okay, so let us see what happens then. That is CH3 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 OH. So what happens? This CH3 group will be moved and be placed here, so that reaction will come like this, right? So now, as this bond is broken, and this OH will be converted into double bond O. Okay, so that's how we are getting a ketone here, right? So that is what is pinacol pinacolone reaction. Now, if there is a benzene group presence, that means C6H5, it will have the moving ability more than this CH3 group. Okay, so if there was in between in these two groups, let us assume that there is a molecule like this, that is C6H5, and here is CH3 and here is OH. Now H2SO4 is given. What will happen then? This C6H5 will go and be added there. This CH3 will not go, so it will be coming like this. Okay, it is C6H5. So that is what is pinacolone reaction. So let us move on the next. Phase rearrangement reaction. Phase rearrangement reaction. So it's also a name reaction. So please remember it very carefully. Now, if we take this molecule, that is OCOCH3, the ones who don't know how this OCOCH3 comes, for that I am just showing you guys it. That is, if we take CH3CO whole twice O in concentrated H2SO4 solution, it gives it acetyl, it forms a, or it does acetylation to this OH and gives us this product OCOCH3. Now from this, if we want to derive an aldehyde, that is, we have to give anhydride AlCl3 in CH2 solution and give it also heat. So then what happens? The OH will come back and this COCH3 will be added here. Okay, on the ortho position. So that is why it is called a rearrangement reaction and its name is Frey's rearrangement reaction. So it is a name reaction. So please remember it. So Wilsmeyer hack aldehyde synthesis. So what does we do here? That is, if we take a activated group, that is a plus M group, not a deactivating group, plus M group or activated group here, Z, and if we give it a DMSO solvent in NML3 and DMF, it gives us this. Okay. So two products will come here. One will be added to ortho and one will be added to para. But this is 55% and this is 45% in a solution. Okay, that is why the yields are comparatively same, but the ortho is the main product here. Okay.